It's a pleasure to be here. It's amazing actually to realize exactly that just 1 year ago was my very first time ever attending a Skyline user group meeting. So who knew I'd get to be able to talk and share some of the things that I've learned over the last year. Um, like Mike just said, it's really exciting what we can do by building on top of Skyline, and it's similar, I think, to what Gary was just describing in terms of unlocking really a lot of scale. Quick intro. Move Analytical, we're really a new company and just about a year old, and focused very much on unlocking metabolomics capabilities by really integrating tightly between software and consumables. And there's four of us. Only three could make it into the picture that particular day. But we have a lab in Carborough. We're shipping out kits, and I'd love to kind of dive into the process of building one of those today. What I'm hoping you're going to learn is how we're using Skyline, and hopefully some tips and tricks around using the Skyline CLI. And then I just am a believer in the power of an open source community. And I think it's really apparent when we're using the Skyline CLI how many different people and problems have been addressed through Skyline. You can see it in just the breadth of capability that's there, and in some cases the variety of ways that it works together. Gary talked about this, just a moment ago, but I think there's tremendous opportunity in understanding biological insight through metabolomics. I've gotten to work across several different fields before, most recently focusing here in metabolites. What I think is really interesting is that there's so much opportunity to see an interplay between the evolution of a system and then new capabilities for measuring, and evolution of system and new capabilities for measuring. There's just a lot of innovation that's going on. Now, of course, I also, have to say, I think it's probably one of the most difficult of things to measure. There's a lot of reasons for that. And a result of that is that the scientific community has just responded with a huge amount of innovation. I sort of alluded to this, but there's this virtuous cycle, I think, going on where new instrumentation becomes available, new analytical approaches. That leads to better biological understanding, which then leads to additional improvements in instrumentation and approaches. There's a lot of publication that's happening as a result. But one of the downsides of that is that the tools are really fragmented. Mike mentioned a little bit ago that we're sort of kicking off ASMS right now, and I'm sure that when we go to ASMS, we're going to learn about the newest, latest, greatest instrument that's come out, and then we're going to remember that we have to pick up the best column that we ever could hear about, and make sure we're using the right new tubing and the right sample prep automation, and the software and the software and the software, right? There's a lot that's going on that can be very difficult to stitch together. So our sort of thesis is that by using what we're calling a software-defined workflow, we can empower labs to really accelerate the pace of innovation. And Skyline lives at the heart of this workflow in a few different places. And so for this talk, what I want to do is highlight sort of three different areas where Skyline is essential for making this overall workflow possible. Now, the term software-defined workflow, probably isn't super familiar. Certainly, it's intended to harken back to the idea of, software-defined networking or software-defined radio, or any of these processes where you are unlocking much more rapid innovation in a space that is typically or had historically been hardware constrained for iterative cycles. And we can accelerate that dramatically using software. For us, I think I would draw your attention to this sort of bottom right portion here, where there are a couple of feedback loops, and there's feedback between SST and data check as well that I'll talk about. But being able to have feedback loops that are dynamic is really a hallmark of what it means to have a software-defined workflow. When we were thinking about how to build that and how to build software that would allow labs to be able to conduct measurements more quickly, more efficiently, more accurately, we kind of identified several different design goals for what needs to lie right at the heart of that. It needs to be flexible, needs to be able to support all the vendors, needs to be familiar to security teams who want to get software installed, tested, etc. Probably no surprise given where we are today, but Skyline just fits that bill really well. It meets all these check marks, and the result is that we could build on top of the Skyline CLI. If you've downloaded Skyline recently, you may or may not have noticed the little Skyline runner standalone. It's just this tiny little shim that will find the Skyline installation on the machine and run it. That said, there maybe has not been quite as much attention on, but I would certainly encourage people to take a look at the Dockerized version of Skyline that is now being distributed and supported by the team as well. It's built with Wine for Windows emulation. The result is that we can run our app in a fully cross-platform way on any system and provide a really high-quality user experience, but also get to rely on the robustness of Skyline for raw data processing, for extraction and quantitation workflows that all then happen in a fully auditable way. So I mentioned sort of three areas where we take advantage of Skyline. The first is providing the language for designing an assay and then in a specific experiment. The kit that we've developed most recently is for bile acids measurement. And it's a targeted assay, but we use untargeted data collection with HRMS. And the result is a lot of discovery potential for enriching analytes past what is part of our initial workflow. In this initial phase, what happens is users define, we tell us about the sample, the matrix, everything that we have in terms of understanding the context for the experiment. And then we build the protocol for everything from sample prep to chromatography and prepare run lists for acquisition. We have sort of a concept at the heart of what it means to be an experiment that we call the model version. And this is where we stitch together everything that we need in order to understand how to process the assay from beginning to end. And you'll notice Skyline really sits very prominently in this, which I think is really a cool thing. So walking through these just a little bit, the kit type is our reference to all of the information about the calibration materials, the internal standards that are used, concentrations, QCs, all of the consumables that we ship as part of a kit. On the right-hand side, you see the instrument configuration. And of course, the specific instrument, both chromatography, the source, and the mass spec are important for understanding how we're going to process the results. The analysis settings is where it's kind of, I would say, a whole separate talk. That's kind of the magic of how we do all of our peaking. This is the kind of machine learning and AI portion of our workflow where we've trained models that are tailored to the specific assay that we've designed. And then, like I mentioned, Skyline is like the last component. That's where everything gets sort of baked together. And we build that out of sort of three different components. First is the analyte list. I'll talk about that in a second. And then we use a lot of custom reports and then Skyline files. I want to talk about how we build those. We do that dynamically for each particular model version. So a combination of all of those parameters get stitched together in order to build a custom template ready for a specific project. I think of what we've got in our what we call colloquially the Analyte CSV a little bit like an HMDB++. It's a single source of truth for everything we know about all of the analytes that are under question. The key things that are being added there are relationship to internal standards, concentrations, like I mentioned, and then chromatographic characteristics. One thing I'll just mention, in the spirit of this as being an advertisement for the Skyline CLI, and then also hopefully some tips and tricks, I find it kind of striking that in this one single workflow, you get the parade of every possible data interchange format. So we start off with the CSV. Skyline prefers XML for their internal format, except when you're loading transitions, which are required to be TSVs, and IRT, of course, is inexplicably a SQLite database. We currently don't have a Skyline CLI option for building the IRTDB, so we just do that manually. But the result is this Skyline template that we can build, and then we go through and validate as on a per model version basis in RCI to make sure that everything is tracking. We get to take advantage of Skyline for computing isotope and precursor on the basis of chemical formula and so forth. The next area is testing. And our vision for testing is that we want to have minimum tests with maximum diagnostic potential. And as a result, we lean heavily on custom report definitions. We use two different kinds of data checks or tests, the data checks and the SSTs. For both of those, we've distilled the tests that are run into just 5 core types of tests. And then across any given assay, we define the acceptable ranges and parameters in conjunction with the entire experimental setup. So when we're sitting down to build the kit, we have essentially these kind of Lego blocks that we can piece together and then export a report from Skyline and rapidly compute the result of a test. One cool side effect of that is that you're not really running tests anymore. You're just sort of watching them run. Once you begin data acquisition inside our application, we begin a polling process where we just start watching for files to be written on disk. And as soon as the new file is done, we kick off a job that interacts several times with Skyline. We import data into this custom template that I was just referring to. We extract the chromatogram and our custom report, work that through our data check, and end up with a per file measure of the kind of key, like I said, minimum test, maximum diagnostic potential insights into what's going on in that experiment. And the result is that we can surface failures very, very quickly for a user. So they can say, look, we need to just stop collection or identify a case where maybe sample prep didn't go right. In this example, there was a column where it already had sort of lost its efficiency and so was no longer able to separate some of the critical pairs, and we could flag that for the user right away so they know to go take an action in the lab. And then finally, we use Skyline as a way to provide a modular framework for robust computation. So we can give users full transparency into all of the data processing that happens while also not forcing them into any data processing at all. I mentioned the model that we use in our MoveApp. And I know there's lots of models out there, and of course I think ours is the best. What it does is it provides a peak picking that sits on top of the native Skyline version, and it's very tightly tied to the specific chromatography and standards that we have designed. And it also allows us to surface QC stats and plots that allow the user to dive a little bit deeper into the same kind of workflow that I was just describing a moment ago with data check. But instead of looking at things on a per replicate basis, sort of zooming out at the per batch basis in order to identify problems that maybe were systemic, again, like more on a sample prep side of things. So this workflow, we hit Skyline a bunch of times throughout it, and because it is a little more dynamic in terms of different feedback loops, there's couple different conditions. But fundamentally, it's pretty straightforward. I mean, we build the custom Skyline template, we import data into it, we import the annotations, we generate a report. We take all of that information together with chromatograms when we're doing the custom peak picking, and we perform our custom peak picking. We then load all of that actually back into Skyline, so a user sees a full annotation of exactly what changes we made in native peak picking and why. And they end up with a report that shows exactly all the analysis that's happened. The result is, I think, really exciting. In fact, like, you never see these kinds of results, I feel like, where we ran, as a part of our bile acids kit development process, a study across 6 different labs. And all of those labs kind of were able to go through the process using the software. And in cases where we identified a data check failure, meaning what I was referring to earlier, where we identified early that resolution would be impossible. We missed those small number of cases as sort of, I think, is necessary. In all other cases, we were able to correctly label all of the critical pairs and all of the broader analyte set coverage that's part of the panel. I mentioned then that that's sort of not the end of the story, because the user then gets a leave behind artifact that includes the full history of the experiment. Finally, just a couple of things I've flagged in terms of what happens with using the Skyline CLI. I mentioned already, there's just like a lot of different file formats that I think show naturally the result of a software product that's been growing for 18 years and has seen development across a huge number of different people. Lots of lessons that we've learned. Hopefully these will become some fun YouTube tips as part of the Move Tips series in the future. But I just finally want to say thanks for the chance to be here. We'll be at ASMS, and yeah, thank you all very much.